Modeling of coupled circuits. Each circuit contains a voltage source and the respective mesh currents being I1 and I2. Applying the KVL for the above circuit, we will get V1 equals to R1 I1 plus L1 dI1 by dt plus or minus M dI2 by dt. Similarly, V2 equals to R2 I2 plus L2 dI2 by dt plus or minus M dI1 by dt, where the above equations plus here when flux acts, negative when flux opposes. Assuming a sinusoidal voltage source at steady state, the above equation further modified as V1 equals to R1 I1 plus j omega L1 I1 plus or minus j omega M I2. That is equation 1, 2. So equation 1 is modified like this, and equation 2 is modified like V2 equals to R2 I2 plus j omega L2 I2 plus or minus j omega M I1. Then V1 equals to R1 plus j omega L1 of I1 plus or minus j omega M of I2. V2 equals to R2 plus j omega L2 of I2 plus or minus j omega M I1. Write these two equations in matrix form, then you'll be getting V1 V2 equals to R1 plus j omega L1 j omega M plus or minus j omega M R2 plus j omega L2 I1 I2. Here the impedance matrix Z equals to Z11, Z12, Z21, Z22, in which Z11 equals to R1 plus j omega L1, Z12 equals to plus or minus j omega M, Z21 equals to plus or minus j omega M, Z22 equals to R2 plus j omega L2. Here also plus is for when the flux is going to add and negative is for when the flux opposes. This is regarding modeling of coupled circuits. If this video is useful, please like, share and subscribe. For an ideal transformer shown, find the input impedance. Assume the load impedance to be ZL and flux is adding. The ideal transformer is modeled in the circuit as shown here. Then the V1 is given by R1 I1 plus j omega x1 I1 as the flux is adding plus j omega M I2. V2 which equals to 0, that equals to R2 I2 plus j omega x2 I2 plus j omega M I1 plus Z2 I2. Writing I2 terms at one side, R2 plus j omega x2 plus Z2 of I2 equals to minus j omega M I1. Then I2 equals to minus j omega M I1 divided by R2 plus j omega x2 plus Z2. Now substitute this I2 value in equation number 1, then you'll be getting V1 equals to R1 plus j omega x1 of I1 plus j omega M of minus j omega M I1 divided by R2 plus j omega x2 plus Z2. Now taking I1 common from this, R1 plus j omega x1, j into minus j plus 1, so plus omega square M square divided by R2 plus j omega x2 plus Z2. ZL, here also ZL. Input impedance, Z input equals to V1 by I1. Then Z input is equals to V1 divided by I1. So R1 plus j omega x1 plus omega square M square divided by R2 plus j omega x2 plus ZL.